All right. So how do we actually restart? Okay, we're going to move down. Yeah, go ahead.
Sorry, can you go back?
Sure.
So does that mean time step 8, 12, and 6 are redundantly checkpointed? We have 2 copies of those 3 times.
Okay. 8, 12, 8, 12, and 6?
Okay. We still have checkpoint 1, 2, and 3 saved, and we have all of those time steps saved as well.
No, these are saved. So, okay, let's make sure we're using the same language. So time step 6 is saved to QUICKSAVE 3, right? Time step 8 is saved to QUICKSAVE 1. But earlier, time step 2 was saved to QUICKSAVE 1. So it overwrites what was in those files. So
Then it's gone.
yeah, then it's gone. Yeah.
So it's no redundancy.
I guess what's the difference between the quick save files and the output?
They're different time steps.
If did you? I guess you know, in our earlier example, we were checkpointing every 2 iterations.
Yeah.
Did you change that? Because in this one it was meant to be 5, so they're not being written at the same cadence.
Yeah, no, mine looks like what you have.
And then did you clear your checkpoints directory? You may be seeing something left from before. So in this example, if we had stopped at time step 6, QUICKSAVE 1 would have contained time step 2.
Can you ls your checkpoints?
Yeah, sure. Let me see.
See if I have it.
Yep. So let me just make sure I believe that's it there. Yeah. So if you had run.
Yeah, so I guess my question is, what's the difference between the files that have the quick save prefix and the files that don't?
Yeah. Okay. So the files that don't are determined by the checkpoint interval. So that's like you saying, I know every 100,000 time steps, I want to make sure I've got a checkpoint, just for whatever reason you've decided that's an appropriate interval. But maybe 100,000 time steps takes you 5 hours, right? And so you'd like to checkpoint more often than that. So what happens is that other checkpoints can happen more quickly, and they rotate in and out of these. In this case, we said we want 3 quick saves. And so initially, time step 2 is written to QUICKSAVE 1. And then later, that was overwritten by time step 8, based on the checkpoint log. Does that make sense?
But it has the same complete information.
Yeah.
QUICKSAVE has exactly this, it has a full set of information, just like the 0, 0.
But you'll never have a numbered checkpoint that contains the same information as a quick save. If they come about on the same time step, a numbered checkpoint is written.
So how often in your mirror runs, for example, would you be doing a quick save?
I'll do quick saves fairly often. I try to do every 30 minutes or so, and then I'll do the which actually there's a flag we'll talk about in a minute that lets you do that, and then I do the large ones like every 100,000 time steps. That's just my it's an easy bookkeeping thing to do. So usually I run things for like 1 or 2 million time steps, and so 100,000 gives you pretty good sampling across that. Okay. So anyway, you can look at the log though to see. Basically, if you say I want to know what's in QUICKSAVE 2, start at the bottom and work your way up until you see 2. And so in this case, it would have been 12, but in the earlier example, the one you guys actually ran, it would have been time step 4 is saved in QUICKSAVE 2. So how do we actually restart from a checkpoint? Okay. So what we do, we go down to the initial conditions name list. Okay. And there's 2 flags we care about. One is the init type, and we set that to -1. Okay. -1 tells Rayleigh to read a checkpoint. Then we set the restart iteration to some number. Okay. And so there's 3 possibilities for that number. It can be positive, it can be negative, or it can be 0. Okay. That's true of many numbers. So it is in fact a number. Okay. So if you specify a negative number, it's telling you to restart from the quick save. If you specify 0, it's telling you to restart from the last checkpoint, whatever that was. Quick save or standard, it doesn't matter. And if you specify a positive number, it's telling Rayleigh to restart from a numbered checkpoint file. Okay.
So you better not delete your log file.
Yeah, that is right. There's no reason to delete it. It's just a little tiny text file. But if you care about what's in the quick saves, yeah, you need to be careful. So usually I just leave it in the directory for the entire run. It will just append to that file. So, yeah.
What happens if you set the restart iteration to a positive number that doesn't actually have a checkpoint?
It will crash. I forget if it exits cleanly or not, but it will complain. It'll say it can't find the file, and then I think it just crashes. So, yeah.
So how it will be if we start a program? So how the restart log will be? So is it overwriting or appending?
It's appending. Yeah, I mean we can do that right now. So if we look at your really quick before we go on, right? Everybody, kind of look at your checkpoint log, okay? And now let's try restarting from time step 10, say, okay? So we'll edit our main input, and we go down to the initial conditions name list. Okay, we set init type to -1, and we'll set the restart iteration to 10. Okay, this is now not benchmark init. This means restart from a checkpoint. By the way, this is an example of how you can put a comment into the input file. Just put an exclamation point. Okay. All right, so we'll run this again for 10 time steps. Actually, I'll leave that up for just a second.
So Nick, just in terms of this init type, that's just a binary thing, is it then? The 1 or -1 or?
No, there's actually several, and so we're going to cover those in the next module. But the init type 1 sets the hydro benchmark. Okay, so we've got init type -1 and restart iter 10. Okay, and then I'll just in my other window here I'll run that. Okay, what you'll see it starts now. It's saying now it's on time step 11. Okay, so it picks up where it left off. In the preamble, it will tell you that the init type is restart, and it tells you what time the simulation was at when the checkpoint was written. So it tells you where you're starting from. Okay, and now if we look in our checkpoints directory, okay, we've got numbers up to 20, right? We've got 5, 10, 15, 20, but we still just have 3 sets of quick saves. And then if we look at our checkpoint log, we see that we have the old information, and then we have new information telling us when the different quick saves were written. Okay. So you can play around with this. You can try, for instance, why don't we try restarting from quick save 1, right? So that would be time step 18. So restart iter. So we'll set that to -1. That means look for quick save slot 1. Okay. And then okay, and then we run the code and we see, okay, we were restarting from time step 18. So it picks up at time step 19 and goes on for 10 time steps. Okay. And then my checkpoint log now goes out to 28. Okay. And notice it looks like we have some redundancy here. We restarted from time step 18, so it picked back up and dumped at 20 again. Right? So this is where the log ended before, but we restarted from there, so it dumps. You'll see some of that. But this lets you see what was done. And then the last checkpoint file, if you look in checkpoints, there's another file, last checkpoint. That actually just tells you what the last checkpoint was. That's really for Rayleigh's use.
And it overwrote the 20. Yeah.
Yeah, it did. It wrote 20 again because we had started at 18, and then it's trying to write a save every 5th iteration. So When you say your checkpoint interval is 5, it's actually doing division on the time step number, integer division on that mod division. So it's not relative to when you started, which is kind of important.
It overwrote previous.
That's right. It overwrote what was in those files. Yeah.
Is that true of all the outputs?
Yes. Yeah.
So it even overwrites non-quick saves in that particular circumstance?
Yeah. We restarted from 18. So yeah, you have to be a little careful, I guess. But if you're restarting from 18, you probably weren't happy with 20, right? So, but yeah. Okay. All right. Oh, and then one other flag. You can also use this instead of quick save interval. And this, you can say, how often do I want to write my quick saves? Okay. And then if this is set, it will override whatever's set by quick save interval. If you have them both set, it will use this instead. Yeah. I was just about to say, are there any questions?
Yeah, that's fine. Can we carry the checkpoint files for the run using different level of processor?
Yes, thank you. That's actually a good question. These things are written as though they were written by a single process. They're written using MPI I/O. So if you run with 100,000 cores or 5 cores, the files have the same structure. So yeah, this is not you don't have to worry about collating things and post-processing or anything like that.
What about a different grid size?
Oh yeah, you can. Actually, that's a good question. Let's do one of those really quick. I didn't think about that. So let's edit our main input file. Okay, and let's change our n theta to be 96. Okay, and we'll restart. And let's restart from the last checkpoint. So, hang on, I need to be out of that one. So n theta is 96, and we'll set our restart iter to 0, which means the last checkpoint. And then we will run the code. Okay, and it will print a message. It'll say, oh, okay, the horizontal resolution in the checkpoint is lower than the current resolution. And so what it does is it just initializes those arrays with zeros out and those other spherical harmonic components. And then let's try something else though. Okay, you can change the resolution down. So we'll set it back to 48 and we'll restart from the last checkpoint. Okay. And now it tells you what it's doing, and it says this might not be a good idea. Okay, because normally you probably don't want to lower your resolution. You can upgrade the radial resolution. You cannot downgrade the radial resolution right now. Okay, that's kind of an important point. And this has to do with boundary condition enforcement. Okay, so you can upgrade or downgrade horizontal. You can upgrade radial, but you can't downgrade radial.
So that decision in terms of that advice is only just generic advice. It's not looking at the power.
No, it's just generic. That's why it might not be a good idea. It might be a wonderful idea.
What do you think?
Yeah, this is just calling your attention to the fact that you're something unusual. Okay, all right. So that's that. So now let's move on to actually manipulating the physics.